Bismillahir Rahmanir Rahim. Assalamu alaikum students. This is Hamza Noor, and in this video I'm going to solve some questions from the topic integration, International A-Level Edexcel Pure Mathematics 4. First of all, we have January 2021, question number 5. So using the substitution u is equals to 3 plus under root of 2x minus 1, find the exact value of this definite integral. 4 upon 3 plus under root of 2x minus 1. We need to integrate this with respect to x, upper limit 13, lower limit 1, giving your answer in the form of p plus q ln 2, where p and q are integers. So we found this question is worth 8 marks. All right, so first of all, in this case, I would say that integration by substitution, the first intention would be to convert this definite integral, which is in the form of x, completely in the form of u, which includes three things. The first thing is that this expression must be converted in terms of u. Then in place of dx, we need something in terms of du. Okay, so dx would be replaced by du, so that we can integrate the function. We can integrate the function which is in terms of u with respect to u. And the other thing is we need to introduce new limits over here. Originally, this upper limit 13, lower limit 1 is of x. We need the limits of u. So our intention is to convert this complete definite integral in the form of u. Okay, and for that purpose, we also need du as well. Okay, so first of all, we are given that the substitution is u is equals to 3 plus 2x minus 1 whole thing raised to the power half. So first of all, we are going to differentiate this. We are going to find the derivative of u with respect to x. So we will find du over dx, so that we can make dx the subject of the equation, so that we can substitute something in place of dx, so that it can be converted into du. So we need to differentiate the substitution first. So du over dx is supposed to be this. When 3 is differentiated with respect to x, it becomes 0, and 2x minus 1 whole thing raised to the power half, and this will be differentiated. This will be half multiplied by 2x minus 1 whole thing raised to the power minus half, and then multiplied by the derivative of 2x minus 1. So this 2 and this 2 will be cancelled out. Therefore, you can say that du over dx is supposed to be 1 upon under root of 2x minus 1. Now, after this step, what you need to do, you need to make dx the subject of the equation. Okay, so if you make dx the subject over here, so du will be equals to dx upon under root of 2x minus 1, and when we make dx a subject, so this will become under root of 2x minus 1 multiplied by du. As simple as that. Now in place of dx, we can actually write under root of 2x minus 1 multiplied by du. Now what we need to do, we need to introduce the new limits as well. Originally, this upper limit 13 and lower limit 1 is of x. We need to convert it into u by using the substitution. U is equals to 3 plus under root of 2x minus 1. So now we are introducing new limits. Okay, so u is equals to 3 plus under root of 2 times 13 and then minus 1. So 13 times 2 is 26, 26 minus 1 is 25. So 3 plus under root of 25 means 3 plus 5. So u is supposed to be 8. And then u is equals to 3 plus under root of 2 times 1 and then minus 1. So u is equals to 3 plus under root of 1, which is 1. So u is equals to 4. So the upper limit of x is converted into the upper limit of u, and the lower limit of x is converted into a lower limit of u. Okay, so now just like this, that upper limit is 8, lower limit is 4, and 4 upon, in place of this complete 3 plus under root of 2x minus 1, we can put u. So 4 upon u, and in place of dx, we can write under root of 2x minus 1 multiplied by u. Under root of 2x minus 1 multiplied by du. But as we can see that on this step, what we were trying to achieve is not yet complete. It's not yet complete. I mean, the definite integral is not completely in the form of u right now. So obviously we need to fulfill our intention and we need to put something in place of under root of 2x minus 1 in terms of u. And as we know, the fact that the substitution which is given to us is u is equals to 3 plus under root of 2x minus 1. So if we make under root of 2x minus 1 the subject of the equation over here, so under root of 2x minus 1 will be equals to u minus 3. And now in place of under root of 2x minus 1, we can substitute u minus 3. So this is upper limit 8, lower limit 4, 4 upon u multiplied by u minus 3. And we need to integrate this with respect to u. Now the quotient is in this form. Now what we can do, we can expand and then simplify. So 4u minus 12 completely over u. We need to integrate this with respect to u with upper limit 8 and lower limit 4. And this can be simplified as 4u over u minus 12 over u, upper limit 8, lower limit 4. We need to integrate this with respect to u, and then we can simplify it like this: 4 minus 12 over u. And this is basically the function which we need to integrate now. As simple as that. So when 4 is integrated with respect to u, it becomes 4u. Let me just take a screenshot over here and make some space on this page. So when we integrate 4 with respect to u, so we will get 4u. And when we integrate minus 12 over u with respect to u, we will get minus 12 multiplied by ln u. So minus 12 ln u. And upper limit is 8, lower limit is 4. We need to give our answer in the form of p plus q ln 2. Okay, so 4 times 8 minus 12 ln 8, and then minus, and then 4 times 4 minus 12 ln 4. So 4 times 8 is 32. So 32 minus 12 ln 8 minus 16 and plus 12 ln u. Sorry, ln u, not ln 4. Minus 12 ln 4. Okay. And now we can say that 32 minus 16 is 16. 16 plus 12 ln 4 minus 12 ln 8. And now we can say that 12 can be taken as a constant term, as a common term actually. 16 plus taking 12 as common multiplied by ln 4 minus ln 8. And then according to the quotient law of logs, we can rewrite it like this: 16 plus 12 into ln 4 over 8. So this is 16 plus 12 times ln half, but our requirement is in the form of p plus q ln 2. We need something like this, ln 2 over here. And as we know, the matter of fact that a basic key concept, a basic identity is that ln 1 over a is exactly equals to minus ln a. Okay, because in place of ln 1 over a, we can write ln 1 minus ln a. And since ln 1 is equal to 0, so 0 minus ln a, this eventually becomes minus ln a. So I can say that in place of ln half, we can write minus ln 2. So this becomes 16 plus 12 times minus ln 2. And your final answer is 16 minus 12 ln 2. This question is worth 8 marks. All right, so here we have January 2021, question number 7. Part A is saying that find the integration of e raised to the power 2x multiplied by sine x with respect to x. This is an indefinite integral. And then we have part B as well. So first of all, we have the part A. So as we can see that when a combination of functions, log, algebraic, trigonometric exponential or inverse trigonometric functions is given to you, we use integration by parts. Okay, so here we have one exponential term and one trigonometric term. So the formula for integrating by parts is the integration of uv dash. I mean, the integrand, the function which is supposed to be integrated, it is given to you in the form of u times v dash. When you integrate it, you will get uv minus integration of vu dash with respect to x. And this is basically the integration as the reverse process of differentiating by product rule. This formula of integrating by parts is exactly proven by the fact that integration is the reverse process of differentiating, and this is basically integration as a reverse process of differentiating by product rule. As we know the fact that when y is equals to u times v, so dy over dx is supposed to be uv dash plus vu dash. Now, since integration is the reverse process of differentiation, if I say that, I mean, obviously I would say that if we integrate uv dash plus vu dash with respect to x, we will exactly get u times v. So this is basically integrating uv dash with respect to x plus integrating vu dash with respect to x, you will exactly get uv. So we are making this thing, this subject over here, that integrating uv dash with respect to x, this will give you uv minus integration of vu dash with respect to x. So this is just a little bit explanation on the proof of this formula. You don't need this proof in your exam. All you need to do is just apply this formula over here. So basically the integrand, the function which is supposed to be integrated, it is given to you in the form of u times v dash. Okay, now the question arises, what to take in place of u and what to take in place of v dash. I mean, this function which is supposed to be integrated is e raised to the power 2x multiplied by sine x. I can rewrite this equation like this: sine x multiplied by e raised to the power 2x. So this does not mean that, I mean, the first term will be taken as u or the second term will be taken as v dash. The sequence is to follow the late rule over here. And when we are dealing with inverse trigonometric functions as well, then we follow this LIATE rule. In the late rule, this t, this only refers to the normal trigonometric functions, not the inverse ones. When inverse trigonometric functions are involved, so for that we have this I. So the sequence of taking u first is log, then exponential, and then algebraic, and then trigonometric, and then exponential. And since in this case we are dealing with the fact that we have one exponential term and one trigonometric term, so trigonometric will be taken as first. So u will be taken as sine x. So u dash is supposed to be cos x. And v dash will be taken as e raised to the power 2x. And when we integrate this, we will get e raised to the power 2x divided by 2. So the question, the integrand which is supposed to be integrated, it is given to you in the form of u times v dash with respect to x. So when we integrate it, we get uv minus integration of vu dash. Now, in order to remember this sequence, uv minus integration of vu dash. But I mean, if you write u dash underneath u and you write v underneath v dash, so you can remember this sequence over here, uv minus integration of vu dash. Okay, so u times v is supposed to be e raised to the power 2x over 2 multiplied by sine x minus the integration of e raised to the power 2x over 2 multiplied by cos x. And as we can see, we need to use integration by parts again. So far we have achieved this thing. Okay, now what I'm going to do, I'm going to take this constant term half outside. So e raised to the power 2x over 2 multiplied by sine x minus taking half as common outside and multiplied by the integration of e raised to the power 2x multiplied by cos x with respect to x. Now on the next page, I'm just going to do the working for this thing, integrating e raised to the power 2x multiplied by cos x with respect to x. Integrating e raised to the power 2x multiplied by cos x with respect to x. Again, we have to use integration by parts. So far, we have achieved this thing over here. Okay. So now again, we have to use integration by parts, and we are dealing with one exponential term and one trigonometric term. So according to the late rule sequence, u will be taken as cos x. So u dash is supposed to be minus sin x. V dash will be taken as e raised to the power 2x. So v is supposed to be e raised to the power 2x over 2. And the sequence is like this: uv minus integration of vu dash with respect to x. So u times v will give you e raised to the power 2x over 2 multiplied by cos x minus the integration of e raised to the power 2x over 2 multiplied by minus sin x with respect to x. So far what we have achieved is e raised to the power 2x over 2 multiplied by cos x plus, I can take half as a constant term outside, as a common term outside, and half multiplied by the integration of e raised to the power 2x multiplied by sin x with respect to x. Now, as you can see that we have arrived at the same thing. Now, if you are wondering that we need to do integration by parts again over here, so the thing is that we originally started from this thing, integrating e raised to the power 2x multiplied by sin x. This means that we can continue it forever and we will be getting the same sequence. Okay, so you need to do just one more step over here and it's very simple. Let me just first write each and everything which we have achieved so far from the beginning. Okay. So far we achieved this thing first: e raised to the power 2x multiplied by sin x completely over 2 minus half times the integration of e raised to the power 2x multiplied by cos x with respect to x. And in place of the integration of e raised to the power 2x multiplied by cos x with respect to x, we can exactly write this whole expression over here which we have achieved. So minus half times what? E raised to the power 2x multiplied by cos x completely over 2 plus, again we have an integration. So first we have a constant term outside, half, plus the integration of e raised to the power 2x multiplied by sin x with respect to x. So far we have achieved this thing, and this is basically the outcome of integrating e raised to the power 2x multiplied by sin x with respect to x. So let me just write down that thing over here as well. Let me take a screenshot and take it on the next page. This is basically the outcome of integrating e raised to the power 2x multiplied by sin x with respect to x. And as I've told you earlier, that if we again do the integration by part, we will be getting the same thing again and again. And obviously we don't need to do that thing again. First of all, what I can do over here is this: expand this bracket. So integrating e raised to the power 2x multiplied by sin x with respect to x. This is equals to e raised to the power 2x multiplied by sin x over 2 minus half times half will give you minus 1 over 4 into e raised to the power 2x multiplied by cos x. Just clean the nib of my pen. So minus 1 over 4 times e raised to the power 2x multiplied by cos x. And then we have the integration of minus 1 over 4 times, minus 1 over 4 times integration of e raised to the power 2x multiplied by sin x. So now what we can do over here, we can take this integral, this indefinite integral, on the other side of the equation, so that we can actually make the integration of e raised to the power 2x multiplied by sin x with respect to x the subject of the equation. Okay, so I'm taking this indefinite integral on the left hand side of the equation. So this becomes e raised to the power 2x multiplied by sin x with respect to x plus 1 over 4 times e raised to the power 2x multiplied by sin x with respect to x. This is exactly equals to e raised to the power 2x multiplied by sine x over 2 minus 1 over 4 times. So I can write it like this: minus e raised to the power 2x multiplied by cos x over 4. Now, when these two indefinite integrals are added, so 1 plus 1 over 4, this is supposed to be how much? This is 5 over 4. So 5 over 4 multiplied by integration of e raised to the power 2x multiplied by sine x with respect to x is exactly equals to e raised to the power 2x multiplied by sine x over 2 minus e raised to the power 2x multiplied by cos x over 4. Now, what we need to do, we need to make this indefinite integral e raised to the power 2x multiplied by sine x with respect to x the subject of the equation, so that we can achieve finally this thing. As simple as that. And for that purpose, you know what you need to do, you need to just adjust a constant term. So let me take another one last screenshot over here to make space on this page. So e raised to the power 2x multiplied by sine x with respect to x, this will give you 4 over 5 multiplied by e raised to the power 2x multiplied by sine x over 2 minus e raised to the power 2x multiplied by cos x over 4. And then finally, you will add a constant term c, because you are dealing with an indefinite integral in this case. Okay. So 4 over 5 multiplied by half, this is 2 over 5. So your final answer is supposed to be 2 over 5 multiplied by e raised to the power 2x multiplied by sine x, and then minus 4 over 5 multiplied by 1 over 4. This 4 and 4 are cancelled out. So minus 1 over 5 times e raised to the power 2x multiplied by cos x, and then plus c. This is supposed to be your final answer. As simple as that. Then we have part B, which actually says to use the result of the earlier part. So basically, this is figure 2, which is given to us in the question originally. Let me bring it on the next page as well. Here you go. So it shows a sketch of part of the curve with equation y is equals to e raised to the power 2x multiplied by sine x, where x is greater than or equals to 0. The finite region R is the finite region R is bounded by the curve and the x-axis, and is shown shaded in figure 2. Show that the exact area of R is e raised to the power 2 pi plus 1 completely over 5. Okay, so first of all, obviously what you need the upper limit over here, and that is basically the x-intercept. And for that purpose, in the original equation of the curve, you will put y is equals to 0. So y is equals to e raised to the power 2x multiplied by sine x. It is the equation of the curve. Okay, and as we want, what happened? Yaar, net issue. Actually, my internet connection just shut down unexpectedly. Let me reconnect it. इसी टाइम होना था यार, ये क्या बोलूं मैं. All right, it's reconnected now. All right, so here we are back. So as I was saying that, first of all, we need the x-intercept. Okay, and so that we can actually find this upper limit over here, and then we can find the value of the definite integral exactly in this form. So obviously we need the x-intercept, so we will use the equation of the curve in which we will put y is equals to 0, because at x-axis y is equal to 0. So we are actually trying to find the root of this equation, e raised to the power 2x multiplied by sine x is equals to 0. So e raised to the power 2x multiplied by sine x is equals to 0. And first of all, when e raised to the power 2x will be kept equal to 0. So in order to make x the subject over here, you have to take ln, you have to take log on both sides, and ln 0 will be undefined over here. Therefore, no solution to this thing. No solution to this thing. Then sine x will be kept equal to 0. And as you know, the fact that when sine x and cos x are equals to +1, -1, and 0. So the angles which are given to you on the unit circle, those angles which are lying on the horizontal axis and vertical axis of the unit circle, those angles are actually, I mean, at those angles, sine x and cos x is equals to +1, -1, and 0. And when sine x is equal to 0, so basically x is equal to 0, x is equals to 180, or x is equals to 360. Because each and every coordinate in the unit circle is in the form of cos x comma sine x. So in this case, we are dealing with the radian mode. So I can say that when sine x is equal to 0, x equals 0, pi, 2 pi in the interval 0 till 2 pi. And as we know, the matter of fact that here we have x is equal to 0, and the next root would be at x is equals to pi. So this upper limit is supposed to be pi. Okay, so x will be equals to pi in this case. So now what we need to do, we need to use the outcome of the part A in order to find the exact area of R in this form. So we need to integrate e raised to the power 2x multiplied by sine x with respect to x using upper limit pi and lower limit 0. And as we know, the matter of fact that when we integrated e raised to the power 2x multiplied by sine x with respect to x, what we got actually this thing. So let me just take the screenshot on the next page. So I just know I don't need to rewrite it again. Here we go. And since now we are dealing with a definite integral, so we don't need the c over here. The c will be removed. Okay, so don't mention the c in this part because we are dealing with a definite integral right now. So all you need to do is just put the upper limit pi and lower limit 0. So 2 over 5 multiplied by e raised to the power 2 pi multiplied by sine pi minus 1 over 5 times e raised to the power 2 pi multiplied by cos pi. We have substituted the upper limit pi, and then we have minus 2 over 5 multiplied by e raised to the power 0 multiplied by sine 0 minus 1 over 5 multiplied by e raised to the power 0 multiplied by cos 0. Now, as we know that the value of sine pi is equal to 0, so this whole thing becomes 0. Okay, and the value of cos pi is equals to -1. So this turns out to be 1 over 5 multiplied by e raised to the power 2 pi. Okay, and then this, like it is closed, and then minus sign. And as we know the fact that sine 0 is 0, so this complete thing becomes 0. And then as we know that cos 0 is equals to 1, and e raised to the power 0 is also equals to 1. So this is supposed to be minus 1 over 5. So 1 over 5 multiplied by e raised to the power 2 pi. E raised to the power 2 pi. So e raised to the power 2 pi over 5 plus 1 over 5. But our requirement will be completed when we express it in this form. And as we know that 5 is a common denominator under both of these terms. So therefore, your final answer is supposed to be e raised to the power 2 pi plus 1 completely divided by 5. This working is for 2 marks. As simple as that. This was January 2021, question number 7. All right, so here we have January 2021, question number 9. It shows a sketch of part of the curve with parametric equations. X is equals to 10 theta, y is equals to 2 sine 2 theta. These are the parametric equations over here, where theta is greater than or equals to 0. The finite region shown shaded in figure 3 is bounded by the curve, the x-axis, and the line with equation x is equals to under root 3. The region is rotated through 2 pi radians about the x-axis to form a solid of evolution. Show that the exact volume of this solid of evolution is given by this form: p multiplied by 1 minus cos 2 theta with respect to theta. Upper limit is k, lower limit is 0, and this part A is worth 7 marks. All right. So what we know that the volume of evolution when the area under the curve is rotated through 360 degrees, or you can say rotated through 2 pi radians about the x-axis, the volume is pi multiplied by integration of y square with respect to x. This is the volume about the x-axis. Okay, when the volume when the shaded area under the curve is rotated through 2 pi radians about the x-axis. So this is basically the formula: pi multiplied by integration of y square with respect to x. Okay, so what we are even over here, these are the two parametric equations. One is x is equal to 10 theta, other one is y is equals to 2 multiplied by sine 2 theta. So obviously we need, first of all, we need something in place of dx. We need something in place of dx so that we can convert it into the form of d theta. And for that purpose, we will use the substitution x is equals to tan theta, and we will differentiate this in order to make dx the subject of the equation. So dx over d theta is supposed to be sec square theta, and when you make dx the subject over here, it will give you sec square theta multiplied by d theta. And in place of y, we can write 2 sine 2 theta. So in place of y square, we can write 2 sine 2 theta whole squared. Okay, so volume is equals to pi multiplied by integration of what? I square. In place of y, we can write 2 sine 2 theta. So 2 sine 2 theta is whole square, and then multiplied by dx. And in place of dx, we can write sec square theta multiplied by d theta. Okay, so let me just take a screenshot of this thing and make some space over here. Okay, and so this will be volume is equals to pi multiplied by integration of 2 sine 2 theta whole square, and then in place of dx we can write sec square theta multiplied by d theta. All right, so we need to exactly prove it in this form, that p multiplied by 1 minus cos 2 theta. Okay, and we also need an upper limit k as well. And for that purpose, as we can see that this value of x over here is under root of 3. So we need a value in terms of theta, obviously, because the integrand will come in the form of theta. So we need an upper limit for theta as well over here. So as we can see that x is equals to tan theta, and this value under root 3 is of x. So under root 3 is equals to tan theta. Therefore, theta equals tan inverse under root 3, which is supposed to be pi over 3. So theta is equals to pi over 3. So the upper limit will be pi over 3 and the lower limit will be 0. Since tan inverse 0 is 0, so you can just show it in just one step. Theta is equals to tan inverse 0. So theta will be 0. Okay. So I'm just erasing this part of the working now. Now the main thing over here is to convert this definite integral in this form, exactly in this form. So in place of 2 sine 2 theta, what we can write? 2 multiplied by sine theta multiplied by cos theta. As we know the fact that the identity is that sine 2 theta is equals to 2 sine theta multiplied by cos theta. Okay, so in place of 2 multiplied by sine 2 theta, we can write 2 multiplied by 2 multiplied by sine theta multiplied by cos theta. This will be whole squared and then multiply by sec square theta. And in place of sec theta, we can write 1 over cos theta. So in place of sec square theta, we can write 1 over cos square theta. And this will be multiplied by pi. And here we have the integration, upper limit pi over 3, lower limit 0. Okay. So now what we can do over here is 2 times 2 is 4 and 4 square is 16. So this can be now written like this. Volume is equals to pi multiplied by integration of 16 sine square theta multiplied by cos square theta multiplied by 1 upon cos square theta and then with respect to theta. Okay, so this cos square theta and cos square theta will be cancelled out and you will be only left with like this thing, 16 pi multiplied by sine square theta, upper limit pi over 3, lower limit 0. Now in place of sine square theta, we need to write something in this form. And as we know the fact that the trigonometric identity for cos 2 theta, there are 3 types of identities. Cos 2 theta can be expressed as cos square theta minus sine square theta. Cos 2 theta can also be expressed as 2 cos square theta minus 1. And cos 2 theta can be also expressed as 1 minus 2 sine square theta. So as we know the fact that in place of cos 2 theta, we can write 1 minus 2 sine square theta. So we will make sine square theta the subject of the identity over here so that we can get something in form in terms of cos 2 theta. So 2 sine square theta will give you 1 minus cos 2 theta. And when you make sine square theta the subject of the equation, subject of the identity, you will get 1 minus cos 2 theta completely divided by 2. So in place of sine square theta, we can write 1 minus cos 2 theta completely over 2. And here you go, 16 pi multiplied by 1 minus cos 2 theta completely over 2. Upper limit pi over 3, lower limit 0 with respect to theta. So 16 pi over 2 will give you 8 pi. Therefore, what you are left with, 8 pi multiplied by, the integration of 8 pi multiplied by 1 minus cos 2 theta, upper limit pi over 3, lower limit 0. And finally, we have achieved this form. So therefore, P is equals to 8 pi and K is equals to pi over 3. Exactly in the form which was required in the question. So this complete working was worth 7 marks. And now in the next part, we need to find by the integration the exact volume of this solid of evolution. We need to obtain the value of this definite integral. So upper limit is pi over 3 and lower limit is 0. 8 pi is a constant term outside, so we can keep it outside the integral. Okay, and we need to integrate 1 minus cos 2 theta with respect to theta. So when 1 is integrated with respect to theta, it will give you just theta. And then we have a minus sign. When cos theta is differentiated, it gives you minus sine theta. So this means that when cos theta is integrated, it gives you sine theta. So when cos 2 theta is integrated, it will give you sine 2 theta and then divide by 2. So theta minus sine 2 theta over 2. I mean, all of these, formulas, identities, derivatives, standard integration must be on your fingertips. Okay, so theta minus sine 2 theta over 2. And then upper limit is pi over 3 and lower limit is 0. And we need to evaluate this definite integral. I mean, when you are doing the practice at home, all of these formulas, all of these standard integrations and derivatives must be on your fingertips. But when you are given the formula sheet in the exam, so you can take the help from here as well. Okay. So pi over 3 minus sine 2 pi over 3 over 2, then minus 0 minus sine 0 over 2. Here you go. And then don't forget it to multiply it with 8 pi, okay, because we are dealing with the volume. So 8 pi will also be multiplied in the end. So 8 pi multiplied by pi over 3 minus, first of all, let's evaluate sine 2 pi over 3, sine 2 pi over 3, and then divided by 2. This is under root of 3 over 4. And this whole thing will be 0. Okay. So you are left with 8 pi square over 3 minus 8 multiplied by under root 3 over 4. Obviously, this will give you 2 root 3. So minus 2 root 3 times pi. This is supposed to be your exact volume of revolution. All right. Thanks for watching. If you find my videos helpful, so please like, share, and subscribe. Inshallah, we will meet soon in the next video. Assalamu alaikum.